In this video, we'll be implementing this project end-to-end using Terraform. Hello everyone, if you are new here, my name is Piyush and this is day 20 of 30 days of AWS Terraform. We'll be implementing a real-time project using Terraform that uses custom modules. Yes, I'm going to explain everything about custom modules. What are modules? What is custom modules? What are the differences and everything? And why do we need custom modules? And we'll be implementing an end-to-end Kubernetes cluster with all the infrastructure component like VPC, subnets, OIDC for authentication, secret manager for using and storing the keys that will be used by this EKS cluster, and we'll be doing everything. And if you are new here and if you have just discovered the series, make sure you follow the series in the same sequence. Like if you are new to Terraform or if you are new to AWS, make sure you go through day 0 video, which will have everything, the course structure, the challenge details, because this 30 days of AWS Terraform, it's a learning challenge that is being managed by our community. And yes, there'll be prizes at the end as well. So make sure you go through day 0 video. And if you are not new here, if you are someone who has been following this series from the beginning, then kudos to you for implementing so many concepts, so many hands-on and tasks by your own. I just gave you the direction and you did rest of it. So a huge appreciation for you to do that. And let's continue with this video. And I'm sure you have been supporting the channel. You have been sharing it with your friends, colleagues, and whoever you want to. Okay, so this is a real-time project, a production-grade project, and you can extend it further with whatever you feel like. Here is this concept that we did not talk about yet, which is custom modules. So why do I mention custom modules and how it is different from what we have been doing so far? So let's first try to understand this concept of modules in Terraform. Okay, so what are modules in Terraform? Modules is something, it's just a reusable piece of code. Okay, so reusable piece of code. Now, how it is different from Terraform function? As you already know, in Terraform is not a fully fledged programming language, right? It's a configuration language. So it provides you limited functionality of a programming language. So it only supports the pre-built functions. But if you want to create reusable code, then we can create our own modules and publish it to our GitHub repository. I'll walk you through that step as well. So this is why do we need, okay, it's just a reusable piece of code in which you encapsulate the complexity of your Terraform, and you can just import that module and start using it with few details. Now, there are different type of modules in Terraform. So there are public modules. So these modules are usually published by Terraform providers such as AWS, HashiCorp, GCP, then Azure, then many other providers, right? So that's the public module. And then we also have partner modules. So partner modules are sometimes part of public modules, but these are the partners that have a collaboration with HashiCorp. So if you go to this documentation, right, the Terraform registry documentation, and click over here to the modules, so you will see multiple filters over here. One is for providers. So these are the providers like Alibaba, AWS, Azure, Google, Helm, Nomad, Oracle, and so on. And then from these list of providers, we also have some partners that have a joint collaboration with HashiCorp. For example, let's say this particular CloudPose, I'm not sure what that is, but let's say this is a company who has published their, it has 169 million downloads. So that's the null provider. Okay, so we have been using the null resource, right, earlier. So it's published by this particular company or this particular provider. Now, if you want to use that, you can just go inside that and you can just start using it like this. I'll go through the syntax later on, right? But the way they do that is they are the Terraform provider, right? But they are not the partner. This particular module is solely maintained by them. Okay, so they are maintaining this module. So any updates, any changes, anything has to be done by them. But if we filter it by partner, let's say Google Cloud is a partner. So Terraform Google Modules, that is one of the partner of Terraform. So that means this particular module is jointly managed by Google Cloud and HashiCorp, right? So that's what we mean by partner. It says they are official HashiCorp partner, meaning they are jointly maintaining the module. Okay, so that's the main difference between a public module and a partner module. So partner module is something that is managed by partner plus HashiCorp. Okay, and public modules are managed by the public providers. Now there is another term which is called custom modules. So custom modules is something that is not managed by partner or public modules. It is managed by either community or you or your organization, right? So you can create, like anyone can create custom modules. Okay, so the step is you create the module. Okay, you create a GitHub repo, then you publish the module to GitHub repo, and then you tag the release. Because when you publish the module, okay, I'll just highlight this part. So when you publish the module, you can create a version as well, right? So that is why we are tagging the release. So you can tag the release and you can create multiple versions of your volume whenever you make a new change. So this is version control as well. So that's why we use the module. Okay, we use the module first. It is a reusable piece of code. Then you can encapsulate all the complexity of your Terraform code into the module and then publish it internally for your organization or for your personal use, or you can make it available for the public via a public GitHub repository. And then you can also version control it. You can also tag the release. Okay, and the other thing is you can lock some values. Let's say you want to avoid making any changes to certain values. So instead of putting that in your Terraform code, you put that value maybe hard coded and put that in the module. Because it's been published, if anyone has to make the change, they have to make the change to the module if they have access to it, right? So that's why we need to use modules. That's why it is important to understand when considering a production grade project. Now you must be thinking, why do we have if we have public modules or if we have partner modules, why do we need to create our own modules? Because of the very same reason. Because public module or the partner module, they have been created by these organizations, right? And they take full control over the module, right? You cannot make any changes to the module unless you do the open source contribution, if they are available for open source. And also you have to be dependent on them. So if anything breaks your change, you have to wait for them to fix the change, right? So you don't have the full control of the underlying module definition. But if you create your own module, if you create custom modules, then you retain the full control and you retain who should have access to this module or not, right? So that's why in most of the organizations we use custom modules. Okay, so that's what we'll be doing in this video. We'll be creating multiple custom modules. Okay, and now let's understand the structure of a module or structure of a custom module. Okay, so when you write a Terraform code, let's say whatever we have done, so that's say you have created a main.tf, you've created a backend.tf and a variables.tf, then output.tf and tf vars and so on, right? Multiple files you have created. So this is, let's consider this as your Terraform hierarchy, like the folder structure of your Terraform project. Now this is because you have not specified any module, you have not created any module, but still because you have created everything inside a folder, so this is called a root module. Okay, even though you did not specified any module explicitly, still it's called as a root module. Okay, it's important to understand. So whatever we have been doing so far, we were using root module. We were creating root modules multiple times. Okay, so let's say this is your, okay, let me just drag my VS Code over here. Okay, so let's say in this day 19 video, right, we had a code, and everything inside this directory, like provision directory. So main.tf output, blah 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 variables. So this is inside this particular folder, right? So this folder, which says provisioner demo, this contains the root module. Okay, so that's the root module that you've been using. Now when we create modules, like how do we create? We create similar file structure but inside another folder. Okay, so if we consider, let's say, this as day 20, okay, this is inside day 20. Now this is a root module. Inside day 20 you will have multiple modules. Okay, so one is this, let's say one is this. Okay, there are multiple modules, so I'm just gonna squeeze it down, and this and this. Okay, so it will have the similar file structure, but it will be inside another subfolder. So let's say this folder is for EKS, okay, and this folder is for VPC, this folder is for IAM, right? So this is what we are doing. We are creating a root module which will have your main.tf, and this is from where the execution will start. And inside that you will have multiple subfolders, and these subfolders are your custom modules. So that's one module, that's two module, that's third module. Okay, and you can name it whatever you want. Now how do these modules and root modules talk to each other? So they talk to each other with the help of these variable files, right? So it has variables.tf, and then it will have output.tf. So that's how they talk to each other. And the main.tf of root module also talk with main.tf of your custom modules, right? This is like calling a function with parameters, right? So we define something in the root module. Okay, first step is we source the module. Okay, in source we provide the location. Let's say it has to be inside current directory and then EKS. So this is how we are sourcing the module. That's the first step. That's how Terraform knows, okay, where your module definition resides. If it's over here, then you can just use source like this. If it's already published in the GitHub repository, then you provide the GitHub URL over here, right? And you can specify version of your module as well. So that's the first part. And then inside your root module, you create certain values, right? Because you have sourced it already, but then you create certain values and then value that map with the EKS. I will walk you through that. So don't worry about it just yet. Just understand the structure of it, right? So if we go back over here, so let me just do the full screen. So we have day 20. Okay, so you see over here in day 20, so we have a folder called code, which is a root module. Everything resides in that. So we have main.tf, provider, variables, and so on. And inside that we have again a different folder called modules. Inside modules we have EKS, IAM, secret manager, VPC. All the modules have been created inside this. Now the root module structure is what I have told you already: main.tf, provider, output. And the similar structure will be there inside these modules. So main.tf, output, variables, and so on. So you start with creating your custom module. Okay, so I've created the folder structure, right? And then inside folder structure, let's say you go inside VPC and you create your main.tf. Now, this is like a resource that you have been creating so far, right? So if you go to AWS VPC resource over here inside Terraform documentation, you search with AWS VPC, right? So you will see that this is your like the basic usage, and you can add more details like with tags, with other additional fields. Okay, so similarly from here you can just create AWS VPC resource with, let's say, CIDR block, some other arguments, tags, and so on. Right now this CIDR block needs some values from the variable, right? So let's say var.vpc CIDR, you have created a variable. So this variable should be present in this variables.tf inside the VPC module, okay? Like the local reference variable over here. So if you see VPC CIDR is here, but from where it is getting the value has not defined over here. So it is getting the value from the root modules variable.tf, okay? So if you go to root module and variables.tf, you see over here VPC CIDR and it has a default value, okay? So remember I told you like variables talk to each other from their name and their like the variable files, and that is how they are doing. Now coming back to this, so this is what we did for this. Okay. So now once you have specified your custom module resource block, there are other resources. I will walk you through that. But once you have specified your custom module resource block, then you go back to your root modules main.tf. Okay, so you have created the module definition. Now you have to use that definition in your Terraform. So this is where you will do that. So you go over here. Okay, so I'll explain this to you in a bit, but first let's explain the module. So what's the syntax of module? So you start with module keyword. Earlier we were using the resource keyword, but because now we are using a module, even though we use a public module or a custom module, it starts with module keyword, right? The source will change. If it's a custom module, you give a different source. If it's a public module, you give a different source. Okay. Rest the definition is same. So you start with module, a reference name, and then inside that, now you will see first is source. This is what I explained it to you. Where's the source? It's inside modules folder inside VPC folder. So this is our module name. Okay, so this is the path that matches with this module path. Now it has different field, but you would notice that there are some fields that is not a valid argument, right? So if you go to like, let's say the VPC resource over here, okay, so these are all the available arguments: region, CIDR block, IPv4, and enable DNS support, blah blah blah, tags. But there is nothing called AZs. So how we have used it? Because this is our custom resource, we can pass these values and then it will map to the internal Terraform name. I will explain. So let's say you have entered some value that you want to be part of this resource provisioning, right? So you have created name.prefix, name underscore prefix. Okay. Now this name underscore prefix is var.cluster name. Okay. So you have created a variable over here, and let's see where it is here, cluster name. So you have defined the value. Now this particular resource will have a name prefix. We might have used it later on. I will show you that. But for now, we are just initializing this particular argument with this variable. Now, similarly, VPC CIDR, we can use the same name as well, which is what we have done, equal to this. Now we are taking AZs from a data source. Okay. Now data source is over here. Instead of hard coding what are all the availability zones available, we are just using the data source. It will check what are all the available data source from the current region. And then we are using data.aws availability zones dot available, which is the internal reference name, dot names, and it will provide a list of string. Now we are just doing a slice of it. Okay, it's a slice function that we have learned earlier as well. We are doing just slice of it from 0 to third element. Okay, so it will take those availability zones. So let's say we are taking the 3 availability zones. So it will take 3 availability zones and put that inside AZs. Now, how do we use that particular value inside our module? So let's go back to the module definition over here. Okay, and inside that, let's see where we have used AZs. So inside, okay, over here, you see inside the AWS subnet resource, we have a field called availability zones. Okay, it's an attribute, a Terraform attribute. Over here, we are using the value from var.azs count.index. Okay, now if you go inside this, we'll have AZs as a variable, which is a list of string. And from where it is getting the value? We are getting the value from the root module. Okay, inside root module we have, okay, let's take a step back again. Okay, so we have main.tf over here. Okay, I want you to spend some little extra time on this, because if you understand this concept, the custom modules will be pretty straightforward and easy. Okay, so we needed to use some value, like we needed to create a set of few elements. Okay, so that this is from where we got the value. We assigned that to a variable called AZs. This variable we defined internally inside the root module. Okay, now because we have specified it over, this will be available for the entire Terraform project inside the custom module as well, right? So the values of these variables of what we specify inside the root module is available for the entire Terraform project inside even custom modules. Okay, so we got the values of AZs. We have a set of elements. Now inside this, we go ahead and we create a variable with the same name. Okay, because this is the value that is available for us. We are just defining that variable. We have the value, we are just defining that variable. Over here, it's a list of string. Now in the main.tf, we are just acquiring the value from the variable. Okay, so what we did inside our root, okay, the root module is already here, so let's use this. Inside our root module, we got the value. Okay, az is, let's say, availability zone US Central 1A, US Central 1B, and US Central 1C. Okay, so we got the value over here in the root module, and this is inside your main.tf. Now what we did, we actually in the variables.tf, we have defined the value. So inside over here, availability zones, which is, do we have a variable over here? I don't think we have. Just give me a second. Okay, no, we are using it from data source, so that's fine. We just got the value from data source. Okay, so this value we got from, there was a file over here, let's call data.tf. We use it from main.tf, but it's a good practice to have a separate file for data source. So let's say we got the value from data.tf. Now it is, because we have the value, it is available for all the modules to consume, or the other way around actually, but I'm just walking you through how do we use the value. Now you've got the value. Now you have variables.tf over here in EKS, and in this you have defined az equal to, like, you have defined a variable, right? So you have defined variable as az, which is a set of set of string. Okay, you have defined it over here. And then in your main.tf, what you are doing in your main.tf, you are telling that the variable, which is, what was the variable name inside main.tf? Yeah, availability zones, which is a Terraform attribute for public subnet. You are saying over here, availability zone is equal to var.az count.index. Okay, az is the variable name. Okay, so you are using this. Now you have a variable over here. Okay, you are assigning this value to the availability zone, which is what Terraform needs. But where you are getting this value? You are getting this value from the root module. So in a nutshell, you are defining the values over here, okay, in the module itself, in the custom module, and you are passing the value from the root module. So that's how you're making the interaction between root module and custom modules possible. Okay, so that's important to understand. If you are still confused, maybe just go back to previous few minutes where we have started understanding it and try it out yourself once, then you will get it better. Okay, so that's where were we were at main.tf. Okay, so that's how we got the value of azs. Now we have a few different other things like private subnets, public subnet. We have used the same variables. Now enable net gateway, single gateway, we have used it like boolean true. Then we have defined some tags, public subnet tags, private subnet tags. Okay, I defined the values of it. It's again, it's a map, right? Key value pair. Now how have we used it? Let's go inside main.tf and let's see. Over here, you see we are using var.public subnet tags, which is a variable, and we are merging it with other tags. Okay, so we are merging it with tags, we are merging it with this and using a merge function. Okay, that's inside the VPC custom module. Now let's go back. This is the tags that we have merged. Now the next module is IAM module. Same thing, module, reference name, and then source. Inside this, we are just initializing the cluster name, and rest all the variables are defined inside IAM module. Let's see. So we have the cluster name from the variable. Okay, let's go inside IAM main.tf. And over here, like I told you, when we want to hardcode something, we don't want to make any changes when user provision infrastructure or when user creates Terraform code to provision the infrastructure. So we are hardcoding a policy document over here, right? So it says use this name prefix, which is coming from var.cluster name. Okay, and var.cluster name is our cluster name. Okay, the one that is coming from the root module. Use this as the name prefix and use this policy. Okay, here's the tag, and then there are some additional resources. So remember, I told you it's a reusable piece of code. So you define everything over here inside IAM. Now the next time you have to create IAM resource with IAM role, with policy attachment, and so many other resources, you don't have to write everything. You can just go to your root module, okay, which is over here, and just write this piece of code, and that's all about it. Okay, and it will use everything inside the IAM module. So consider this as a package with main.tf, variables, output, and everything. So we were over here, so it has some required cluster policies, some policy attachment. Then we are also creating IAM role for the node group because we are provisioning an EKS cluster. So that's that. And then again, the policy required policies for node worker policy, node CNI policy, node registry policy, and so on. Then that was the IAM module. Let's go back to main.tf, and then we have EKS module. Again, we are providing values. Similar thing, nothing new. Cluster name, Kubernetes version, VPC, subnet. So these names could be same, and then we can reference it. But like how we are referencing it now, over here, you see, VPC ID, we are not taking it from the variables or data source. We are taking it from modules as well. So, right, these modules can also talk to each other. So this is what we are doing over here. We are taking the value of VPC ID from module.vpc.vpc ID, okay, which is coming from module is VPC. So it will go inside VPC. And from here, it will take the VPC ID, like however it has gotten the VPC ID. So it will take the VPC ID from that like output variable. Okay. So output of this module will become the input of root module. Okay. So let me just make the changes. So, oh no, sorry. So these custom modules does not talk to each other. They talk through root module. Okay. So we are using values inside main.tf, okay, from output.tf of a custom module. Okay, now what we did, we are using like this module.vpc.vpc ID. Oops. Let me just write it below so that it is easily readable. Module.vpc.vpc ID. Oops, so many mistakes. Okay, right. So inside this, not this, actually this. Okay, from VPC we had the VPC ID, right? We created a VPC, so we got the ID. But then how does root module know that we have the VPC ID? From where it will get? It will get when we define that in the output variable. So from there, the root module can get the value. Similarly, root module can talk to other modules via their output.tf. Okay, and I'm just gonna make another arrow over here. Right now, these custom modules cannot talk to each other. Okay, they are independent. They cannot talk to each other. If they want to talk, they have to talk through root module. So if let's say if EKS has to use some value from VPC, so what we can do is first the value is acquired by root module, okay, through output variable, and then we can use the value from the root module in the EKC. Okay, so let's go back and we were over here. So that's the custom modules. We've got the value, defined everything what we want, and then we are using an implicit dependency that this is dependent on IAM module to be provisioned. Similar thing we are doing for secret manager, because secret manager is where we are storing our secret keys for database like DB secret, API secrets, and so on. Okay, database credentials. So we are storing everything inside secret manager, and that's all about it, right? So this is what we have done. We have created multiple modules, multiple custom modules. We have created the root module. We defined everything in root module. We actually sourced all the custom modules, and everything was defined inside the custom modules. The important thing to understand is how these variables are talking to each other, right? What's the dependency and how we are initializing the variables. If you understand this part, then custom module will be a piece of cake. That's the important part to understand. So I would suggest first try to create a simple resource, let's say a VPC. Okay, VPC will have, as you can see, VPC will not just have the single VPC, it will have VPC, internet gateway, and then public subnet, private subnet, elastic IP for NAT gateway, and then finally NAT gateway route table. So there are actually a lot of things, but maybe you can start with VPC, subnet, and internet gateway, just these three things. And just try to see how these variables are working with each other, how root module is talking to the custom module to get the values, how we are defining the values, and how we are actually using the values. If you create those three resources that I told you, if you create that and if you use all these variable interaction, if you are able to provision these resources, then I would recommend going to the day 20 repository and then implementing this entire project end to end by using the documentation and by following the method that I've told you about. Okay. So yeah, that's it about this video. Make sure you do the hands-on, otherwise you know that drill, right? I have told you this multiple times. So let's skip it for now and complete the task, submit your submissions, and I will see you tomorrow with the next video. Thank you so much. Happy learning.